Now, what we are going to do is to arrange our electron configuration, where we will start, ma'am, in writing electron configuration. We will start with 1s. Don't worry, I will put arrow as a guide for you on the next slide. So now we already done putting arrows in our configuration. So here we can see that we should start with 1s, and then we will start with the tip of the arrow for the 2s. So we have 1s, 2s, followed by 2p, and then 3s, and then 3p, and then 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and then 5f, 6d, 7p, and yes, and then followed by 6f, and so on and so forth. So now let's have an example. Let's write the electron configuration for hydrogen. Ma'am, how we will determine the electron configuration for hydrogen or for an element? It is very easy. Just check the atomic number of the element. Like for example, for hydrogen, the atomic number is 1 since it is the first element in the periodic table, and then you will just proceed with the arrangement that I've taught you a while ago, like 1s, 2s, 2p, 3s, 3p, 4s, and then you will stop if you have the atomic number of the element. Like for example, for hydrogen, of course we will start writing in 1s, 1. Ma'am, why is that you write superscript 1 for the hydrogen? That S should contain two electrons, ma'am. It's very okay since I've told you earlier that S can carry maximum of 2, but it doesn't mean that it cannot carry 1. So 1s1, that's the electron configuration for hydrogen, because what we can see here is that its exponent or its superscript already has 1. Okay, so that means this is already the electron configuration for hydrogen. Let's have another example. Let's write the electron configuration for helium or HA. So let's have a note that the electron is equals to the atomic number. So what is the the atomic number of helium? It is 2. So meaning let's stop with the exponent 2. Okay? So 1s2, then that's the electron configuration for helium since we already has its atomic number, which is 2. Now let's have another example. Let's write the electron for silicon, and let's always remember the electron meaning it is the atomic number. So please check the atomic number of silicon in your periodic table, and as what you can see, silicon has 14 atomic number. So let's stop if the exponent or the sum of the exponent has 14 or is already 14. So, let's start with 1s2. Ma'am, why is that it is not 1s1? Because in order to have 14, let's put the maximum, okay, until we reach 14. So, for the first configuration, 1s to the power of 2. For the second, 2s to the power of 2, since we can locate here in the arrangement 1s to the power of 2, 2s to the power of 2. So there are how many electrons? It is 2 plus 2, 4. And then let's proceed since it is not yet still 14. So 2p to the power of 6, since 6 can carry 6 electrons as the maximum. So 2 plus 2 plus 6, it is already 10. And then let's proceed. What's next to 2p? It is 3s. And then what's the maximum for s? It is exponent. What's the exponent for s? It is 2. So meaning 2 plus 2 plus 6 plus 2 is 12. So next we have, do we have 14 already? Not yet. So let's continue. What's next to 3s? It is 3p. And then we will just put 2. Okay, we will just put 2 in order for us to have the atomic number of 14. Ma'am, why is that, ma'am? We do not put the 6 or 3p6 since 6 is the maximum electrons for p. Because if we put 6, we will not hit the target, which is the 14 atomic number. So in this slide, it just highlight as what you can see the exponent. I've put a red dot there so that you can count there are how many atomic number or how many electrons already. So 2 plus 2 plus 6 plus 2 plus 2 is equals 14. So that's the electron configuration for the silicon. Okay, let's have another example. Let's write the electron configuration for oxygen. So the atomic number for oxygen is 8. So therefore, we should have the exponent or summation of exponent, or the sum of exponent should be 8. So let's start 1s2, 2s2, since we already have 4. And then the next, what's next to 2s? It is 2p. So in order to hit the target, should we write 2p6? No, we will write only 2p4 so that we will hit the target, which is 8. So 2 plus 2 plus 4 equals 8. Okay, let's have another example. And then, before I will proceed with the answer, you can pause the video, get paper and ball pen so that you can try it yourself. So for this one, feel free to pause and then continue if you already have the answer. So this is the electron configuration for the magnesium. So we have 12 as the atomic number. So the electron configuration is 1s2, I mean to the power of 2, 1s to the power of 2, 2s to the power of 2, 2p to the power of 6, 3s to the power of 2. So 2 plus 2 plus 6 equals 10 plus 2 equals 12. So that's the electron configuration for magnesium. Now, for your activity, write this one in one whole sheet of paper. So the direction, write the electron configuration for the following elements. Number 1, beryllium. 2, nitrogen, potassium. And then titanium, sodium, phosphorus, vanadium, carbon, aluminum, and lastly, boron. You will write it on 1/4 sheet of paper and then submit it to me via messenger. Okay? And then, there is no, I am very flexible with the deadline as long as you can comply. Thank you so much, everyone, and I hope you will have a good day. Goodbye.